Are you projecting your monitor to this?
Should be, yeah.
And we are live.
Okay.
Hi everybody, we're going to get going with the Seattle GDG Dev Fest for Polymer, and it's academic. So I just want to, my name's Clive, and just want to introduce our two speakers. Jan, who's also sponsor of today's event from Component Kitchen, and Mike, who is our host with Google and also our speaker today of our labs. So, thanks very much.
Yeah, sorry about the video, everyone. I think we're going here. Everything good, Jason? Or?
Yes, sir.
Okay, great. So I am going to start us off with a little message from Eric Beidelman, who's officially in the Polymer team. So let's take a look at this. Oops. I don't hear audio.
I think it's playing through this.
Oh, okay, great. You hear it. But it's not coming through this. Okay. That's not good for
If we change this.
Change the speaker out. Maybe, yeah.
Let's see, sound. Headphones.
Oh, oh yeah, headphones. There we go. Great. Okay, restart that guy.
I'm Eric Beidelman. I'm a developer advocate here at Google, working on the Polymer team and web components. Web components are a fundamental shift for web development. They're going to change everything. They're the future of web development. And we're thrilled that all of you are here today, helping out and learning about them. Welcome to Polytechnic. Throughout the month of November, we partner with hundreds of developer groups around the world to host similar events like this one. We're excited to see what all you guys are going to build today on top of web components. For all of you that are new to Polymer, we actually started the project over 2 years ago as an open source project, and we started it for a couple of really important reasons. First was to gain valuable experience and provide feedback to the standards bodies. This has been really important to kind of evolve the specs over time. The 4 main specs, HTML imports, custom elements, shadow DOM, and templates, these have all improved over the last 4 years, largely thanks to the Polymer team's involvement in these projects. The second thing we wanted to do, we wanted to create a well-lit path for developers. This includes building a set of polyfills so you, the developer, can use web components today in browsers that don't support the native APIs. We wanted to make developers more productive. I like writing less code, and I'm sure you do too. Web components do a whole lot for web developer ergonomics. They allow you to build reusable, declarative, interoperable custom elements. And of course, we're starting a new ecosystem here, an entirely new ecosystem of web components. So we wanted, as the Polymer team, to seed the community with a valuable set of rich visual and non-visual custom elements to show the power of these technologies. Most recently, too, we talked about material design in Google I/O. Polymer has a set of paper elements that you can use to achieve material design in your apps. So with Android and web, now we can create the same app that looks and feels exactly the same. So if you're new to Polymer, welcome. You're going to learn a lot today. If you've already tried it, help someone else out. Upload your stuff to GitHub. Create something reusable, something new. We love your feedback, so please file bugs if you find anything that's amiss. So thanks a lot. Have a lot of fun. Enjoy the swag, and go componentize the web.
Is this still working as a mic, Jason? Okay, great. All right, so that's a nice little introduction to Polymer and what we're all doing here today. I wanted to go over briefly, like what we're going to do. This is the order of business to today. And is everybody comfortable? Has a seat and everything? Any problems? Awesome. So we're going to start out with Jan's talk in the morning, and that's going to give you a great overview of the kind of the web components technology, and he'll explain the relationship of that to Google's Polymer library. We'll take a little break, and then we're going to just start into Code Lab, and I'll be showing how that Code Lab works, and you'll have plenty of time to actually get through that. It's kind of a cut and paste Code Lab, but I'd encourage you to take the time to kind of read what it is you're doing. There's not really any reason to rush. We have, I think, plenty of time to get through it before lunch, and we'll be around to help you get unstuck and answer questions. So then Jan is going to then kind of flip over from just kind of the basics of like how you would actually use a Polymer element to creating your own elements. And this is a talk that we haven't had too many of these now. Kind of people are just learning how to use the technology, and he's come up with a talk for us to talk about how to design elements and what the issues are with that. Then I'm going to talk about mobile web, and Eric in the video said that Polymer is a great platform for designing mobile web applications, and designing for the mobile web gives really good interactive UI, takes full advantage of the screen, and has good ability to enhance it for different form factors. So I'll be talking a little bit about that. And then we have some time for you guys to choose, really what path you want to take. And I would suggest that you could kind of experiment with some other Polymer elements that are in the various directories and places you might look, like Component Kitchen. But there are also a number of other code labs to do. So, and since we're all kind of cozy together at tables here, it might be great if you guys kind of wanted to work together on something too. That would be also something that you could do as well. All right, and then we'll do kind of a discussion and kind of a Q&A to wrap up at the end of the day. So that is the schedule. So I want to suggest a few things to get the most out of today. We're going to start out learning about it, practicing, with CodeLab, and so you really understand how Polymer works in practice and get some working code working on your machine. Then at lunch, I encourage you to kind of, meet your neighbors and find out what they do and get to know each other, because you might be writing some code together later in the day. Then we're going to learn how to make web components, try it out on a mobile device if you have one. I have a few extra USB cables if people need to tether their mobile device to their computer. I didn't really list that in things to bring here today. But you can do some emulation in the browser as well. And then try to build something. And at the end of the day, if you've just played around with a Polymer element that you think is kind of cool, or got a working demo, we'd love to have you kind of come up and give a couple-minute demo as well. So be thinking about that if you want to share something about what you've learned today, or show off something you've done. And most of all, have fun today. So I'm going to introduce Jan. Is there a problem?
Nope.
Okay.
So just one last quick announcement. Hi, I'm Jason. I'm doing the video in the back, but if you haven't registered, or if you just went out back and grabbed the name tag while I was running back and forth, make sure you come see me so I can get your name down. If you don't have a name tag, also make sure that I've got your name down just for attendance purposes. Thanks, guys.
So Jan has been a user experience developer for like 25 years or something, and I worked I think at Microsoft, then went to Cozy. It was a startup here that does kind of family calendar applications, but he's been dealing a lot with kind of the whole idea of like componentizing our user experiences and how to best deliver those. So when Google kind of started working the standards bodies on this web components technology, Jan was one of the early adopters, and then actually started a startup company, which is Component Kitchen, to kind of bring that technology to the world and help us share components. So with that, welcome Jan, please.
All right.
All right.
Okay. All right. So, okay. Well, hi, I'm Jan Miksovsky from Component Kitchen, and I'm very excited to talk to you guys today. I've spoken about web components to many groups. I've actually saw some people that I've seen in other talks I've given, but it's rare to have an opportunity to spend a whole day with a group of people like you, so we can get into more than just an introduction. So I'm going to start with a Web Components 101 talk. Just give you may have heard about it, you may have read a little bit about it, but this is a way to make sure everyone's sort of on the same page. And I'm going to talk about what makes this set of changes different from other equally exciting technologies that are out there, but there's something much more fundamental about the changes that are implied by this set of technologies, and I think it's worth keeping that in mind as you evaluate it and decide what to make of it for yourself or your organization. In the afternoon, I'm going to follow up with a slightly more advanced talk, Web Components 201, and look at specifically how to design components with an eye towards reuse and the implications that that has on, I think, your development process and your design mindset. So we're going to look, today is about web components. Just to start off with a definition, a component is a piece of an application, some bit of user interactivity that's been packaged up into some modular form that can be readily combined with other components to create a full application. And it's that ability to combine things that really make something a component. Components solve some problems that have been previously solved with widget platforms or things like jQuery plugins. If you've ever worked with those, they can solve a particular problem, but you often find that there's a challenge in combining them with an existing body of code. There's just the brittleness of the existing web platform makes it hard to combine things, and that really puts a limit on how much things can be reused and how quickly things can be shared. So web components fundamentally changes that, and we're going to sort of look at sort of the difference that means and what that means for you and your organization. If you step back, I hope to by the end of this talk, what you'll walk away from, if nothing else, is the feeling that these changes, Eric talked about 4 specs, I'll also talk about a 5th, represent the most fundamental changes to the web platform, the language, HTML, CSS, that we use to write applications, I think, since CSS. I mean, there have been some, the invention of the video tag. There's been, things that have moved the web forward. But in terms of interlocking pieces that transform how we create web applications, I think this is pretty major. And, there's a difference between what a framework is able to achieve and what something's able to achieve in the browser. If the browser's rewritten to open up new capability, that really is a qualitatively different kind of change. And so we'll look at that. These changes, everyone has opinions. You'll form an opinion today about these changes. I want to impress upon you how permanent I think these changes will be. I mentioned CSS. You may not like CSS, but it's everywhere. And even if you have managed to get yourself with a particular tool chain where you're not touching CSS directly, maybe you're using a preprocessor or using a visual design tool, you still have to understand how CSS works, because that's how the browser is actually going to paint pixels on the screen. You actually have to understand that. And in the same light, web components are becoming a fact of the web. They're shipping, they've shipped in Chrome for a while now. They will be shipping in Firefox sometime in the next year. They're not too far behind Google. The people at Microsoft are busy considering. And it's also shipping in Opera. Apple is also involved, although I don't know their particular plans for releasing support. But as these specs move through the W3C standards process, they will become a fact of how you build web applications. And like with CSS, regardless of what your opinion is about them, they will be everywhere. And whether you touch them directly or work through a framework that's based on them or use a visual design tool, you're going to need to understand sort of the nuts and bolts of how those things work in order to get the most out of them. We're going to talk about Polymer. Polymer is a framework, and I just wanted to acknowledge my own skepticism when I see someone give a demonstration of a framework. A framework presentation where someone is going to build something on stage is inherently a stunt. Seeing a framework talk and a framework demonstration teaches you about as much about how you're actually going to use that framework to build applications as watching Iron Chef teaches you how you're going to put food on your table at home. So it's not meant to be step by step, okay, follow along all the things I'm doing. You watch these talks and someone says, look at my new framework. It could be Angular or React or whatever. And they give a talk and they start out with file new project or something, and then they write about 5 lines of code and include something, and then they've got like a 3D game engine running, and then they're like, watch, and then they set the multiplayer equals true attribute, and suddenly it's a massively multiplayer 3D game engine, and watch as I make it responsive by checking the work on a phone box. So that's, you have to take this all with a grain of salt. The point of this is not that you're going to be spewing functionality as quickly as I am. It's really meant to sort of give you a taste for what it's like to work with this. Don't get too hung up on the syntax. The other thing with frameworks is, there's just a ton of grammar and syntax you'll see flying by, like, oh, he's using curly braces. Like, I've never seen that in HTML before. And don't worry too much about that. Instead, focus on the underlying technologies, because that's the stuff that's going to be permanent. And I'd hope that you walk away from this talk and from this day with a sense of the scale of the change. I'm going to go through live code. I'm not going to show slides. I think to make sense of code, you need to sort of see it work. And I'm going to go through just a handful of topics, and we're going to cover 7 topics in this introductory talk. There's 5 specs that I want to talk about, and I'm going to go through each of these. Rather than talk about them in the abstract, I want to show where they show up in code, what that means. And I'll also talk about 2 libraries that are sort of independent of the specs. They're built on top of the specs. Web Components JS, also known as Platform, recently went through a name change just in the last week or 2, and then Polymer. So we'll look at all that in the course of covering some code examples. So a lot of components talks that I've seen start with building a component, hello world component from scratch. But I think it's much more interesting to me to consider what it's like to use a component, because no matter how many people are creating components, there's going to be, I think, a much bigger audience of people actually using them. And I think it's important for you to understand what that use experience is going to be like, because that may be the first time that you're actually going to, or people on your team are going to use components. It's going to be using something someone else wrote, and you should have that experience in mind. And if you're creating components for other people, it's important to have their experience. They're a user of your component. You have to think about their user experience. What's it going to be like for them to use it? So I want to start with that. As an example, I want to just pick a common user interface pattern. Components are good at taking what up until now has had to be an abstract pattern or maybe a plugin and building something that's reusable. I'm going to use the common user interface pattern of photo carousel. You see these all the time. If you search for like jQuery photo carousel, you'll get a billion of these things. And we all sort of have an expectation of how these things work. You have a set of images, and the user wants to have sort of next and previous buttons that they can use to go between them. So we're going to start. We've got a very simple page here that just has a collection of images, and we'll go and open it up. And so at the moment, that page isn't that interesting. It's just a collection of images. And what we want to do is take that set of images and put them inside of a carousel. There are going to be 3 steps to this. The first step is to get the component onto the machine or some place where I can point to it with a URL. I'm not going to go in this talk into detail about how to do that. In the code labs, you'll read a little bit more about that. As the code labs will show, you can distribute these things just as zip files. You could have a GitHub URL that someone can clone. There's also package managers. The one that's sort of the most commonly used to distribute components is called Bower, and the code labs and the Polymer documentation talk a little bit about that. For the purposes of this talk, I don't think that that's something you should really worry about. The thing to know is I've just got a set of files here that I've gotten on this machine, and there's one of them called, this one is called basic carousel. We'll talk about it more in detail, but there's a file here, and I want to use that in this particular project. So this leads to the second step in using a component. After you've got it on your machine or someplace where you can point to it, you want to bring it into the page that you're working on. And to do that, we're going to use our first bit of new technology, which is the HTML import spec. So you're used to being able to bring script or CSS into a web page with a link tag or a script tag. In the case of HTML imports, there's a new value for the rel attribute on the link tag. So you've probably done link rel equals style sheet a million times. Here we're going to say rel equals import. And what that lets us do is point to something on this machine. And so I simply reference that with a URL, and that will import everything that's in that HTML file, script, CSS, and HTML elements into this page where I can use it. And then we get to the third step. What's the result of importing all that stuff? Well, some script will run that will register a new custom element with the browser, and that's now we're getting into our second piece of technology, custom elements. So a custom element is just a new tag that you can use in HTML, and you can augment the 100 or so tags that are standard, divs, a tags, p, whatever, with a new tag. So here I'm going to put in, by virtue of having done this import, my browser, this specific page will now understand a new tag. We've just added something new to the language. And so we'll close that, go like that. And with that, if we go back to our page, we see that we've got just one image at a time now, and we've got the ability to navigate left and right. You can't see this, but I'm going to now, it does some other tricks. I've got some keyboard support, so I'm pressing the left and right arrow keys. Other things you can't see are there's a little bit of work done behind the scenes to make this particular carousel slightly more accessible to assistive technologies like screen readers. So there's a package of basic stuff. It doesn't look particularly amazing, and that's by design. General purpose components in general should have very generic visual presentations. But this is a start. And if we consider the user experience of, say, an HTML author, someone who's comfortable editing HTML but doesn't consider themselves to be a developer, think about the set of things that that person can accomplish today purely in HTML. Like they might be able to create a blog post or create some marketing materials. But there is a pretty severe bound in what they can do. With this, still staying within the world of HTML, they can actually accomplish a lot more if someone gives them a component that embodies something. They can bring that into their page and then make use of it. They work with these components just like they work with standard HTML elements. So just like you can put images inside a div, you can stick them inside of another component. We can also do things like change the behavior of this particular one. Let's do a different effect by setting attributes on it. And this is the standard thing you do in HTML. And now when I go, there's a slightly different visual effect, which is covering or revealing the images as I go through. If the author here wants to change the appearance of it, they can, but we're now going to get into our third bit of technology, which is shadow DOM. So I mentioned that components are fundamentally different from widgets or plugins that have gone before because you can readily combine them. And for things to be combinable, you need to be able to insulate the effect that a component has on the page so that it's not polluting the global namespace, it's not adding a pile of styles. I think we've all had, if you've worked with plugins, you've had this experience where you add a plugin to a page and it wants to style something. It wants to change all the buttons on the page. And now your buttons end up picking the style that the plugin author defined, which is a disaster. If you can try sticking one plugin inside of another, and usually things go sideways because they're just interfering with each other. So to allow web components to coexist on a page without affecting the page or without affecting each other, every component is surrounded in a semi-permeable boundary, and that goes by the name of a shadow document. So if we drop into the Chrome debugger here, and so here we see our basic carousel tag, and we see a set of images inside of it. And there's this new thing here. It says shadow root. And notice that out here we don't see anything. There's a button here, this right button, and there's a left button, but we don't see them out here. Instead, those things have been tucked inside of this shadow root. The shadow root is basically saying, there's a little document back here, hidden from the page, generally speaking, unless the page wants to know about it. The page doesn't need to know about it. But that document sitting there, it's a small document that the component has created called a shadow DOM tree. And the component can put anything into that it wants, anything that could put into the outer page, you can stick inside one of these documents. So there's a div, and inside here we see that there's a button on the left and a button on the right. These were added by the component, but the outer page doesn't need to know about that. And in fact, that's that opacity is critical to the ability of these components to coexist. That if you notice this button has an ID on it, well, the outer page could use an element with the same ID, and they'll be able to coexist because of this boundary. And to get into the idea of styling, when you style something, you apply a CSS selector that's going to look over the page for elements that satisfy that criteria. If we issue a command here to look for all of the buttons, well, let's do images first. So I say, show me all the images on the page. The page says I have 5 images. So these could all be styled with page CSS. If we ask the page, how many buttons do you have? It says, I've got nothing. There are no buttons on this page. So in other words, if you had CSS on this page that was styling buttons, it wouldn't affect the buttons inside here. Now, some of the time, you do want to change what something looks like. A component that only had one visual presentation wouldn't be that interesting. If you're willing to buy completely into a particular visual aesthetic, like material design and paper, then that's great. But a lot of times you want to take, someone wants to create something that's general purpose, and then you want to use it and apply your own application's visual brand to it so that it looks and feels like it's part of your app. That's critical to you. So you want to be able to style things. So to make that happen, there's a new CSS selector that lets you deliberately cross over that shadow document boundary. And so if we say we want to look inside the shadow of basic carousel for buttons, then the page says, oh yeah, there's 2 buttons there. So we can now take advantage of that. If you want to do that, we can come back to our little carousel page here and write some CSS that's going to use that selector. I happen to have written a page of CSS here that uses that CSS selector. We'll just import that. So this now has a slightly different visual presentation with different round buttons with some alpha effects and so on. So the point here is that you can then apply whatever you can do in CSS, you can do to a component. I think that that's about all that I want to say about, oh yeah, let's, I've been doing, so one of the things that's very exciting to me is that all of this that you've been looking at is all native web components because we're running inside of Chrome. So if you look at this page, there's nothing else that I had to load to get all this stuff to work. But there are other browsers out there. So we'll look at this page inside of Safari right now. So Safari, this is the same page. It doesn't know anything about web components, so all the Safari page is seeing right now is a bunch of images. It doesn't know what to make of basic carousel and effectively treats it as a div. It's not particularly useful. So we're going to take a look at the first of the 2 libraries I mentioned, Web Components.js. This is a JavaScript implementation of the specs above. So in Chrome, there's a native implementation. For the rest of the browsers, you can use a JavaScript implementation. And one of the best tricks that Google did in promoting these specs is that as they went, they were also creating this library of polyfills, this compatibility layer that would let these technologies run on older browsers. So when there were decisions about how to do something, they could prefer the solution that was easy to implement on an older browser. And we can take advantage of that just by loading that library. And now, if we load that, so now we get sort of the very basic form of our carousel. That's running, although the styling's gone. So there's a little bit more that we need to do to make that work. If you're writing web components and you're putting styling inside of components, that styling, like the carousel's stock CSS styling, that comes along for the ride for free. But if you're doing something like applying a style sheet that's just a loose CSS file, you have to give Web Components JS a little nod. You say, I want you to fix up the styles inside of the style sheet so that they will work on an older browser. Remember, this style sheet has a shadow selector that Safari doesn't understand. So we can take advantage of the shadow DOM shim inside of webcomponents.js by applying an attribute to that style sheet import. So now we see the styles applied. And if you're looking, there's one more thing I think it's worth doing. If I refresh this page, notice down here there's a little bit of flash. So this is the same kind of flash that you see the FOOC, where you have, say, typography. You're trying to load a font, and the user sees a bunch of Times New Roman for half a second, and then suddenly it turns into Futura after your font loads. The same thing can happen with web components, and to avoid that flash of unstyled content, we can add an attribute on the body tag called unresolved, which basically is just a hint that nothing should be shown until the components have been loaded and fixed up by Web Components.js. So now I want to hit refresh. Everything kind of loads smoothly. So this works on Safari, it works on Firefox, it works on IE back to IE 10. Some of the shims, I think, there's one or two that actually can be used in earlier versions, I think IE 9, as well as Chrome, mobile Safari. So pretty much everywhere that you're gonna be targeting these days, you can actually use web components through Web Components.js, which is obviously a huge advantage that you don't have to wait for browser ubiquity and native implementations before you take advantage of this. Okay, so enough of showing just this is the user experience. This is what it's like for someone to use a component. I think it's not a big change to the world of the HTML author. There's a little bit that's new. They're going to have some new tags to explore, but basically they're going to work with this just like HTML, and that's an important thing to maintain because there are zillions of people in the world everywhere. There's people who understand HTML that don't consider themselves to be developers. Could be a small business owner. Could be a student, and you're going to be able to give them a lot of power by delivering them a web component. Let's look at the experience now of authoring a component. So for this, I want to pick a different user interface pattern. This one's very, very basic. We'll just go to a site like Amazon, and there's this box at the top of the page. There's a text box and then a button to the right of it that does something when I type into the box. And this is the kind of pattern that's it seems so trivial that not a lot of time is spent thinking about it. Well, I want to have a text box and a button next to it, and when the user presses the button, I'm going to do something with that text. So we just end up copying and pasting, like, oh, I'll go find some place where I did that before, and just copy and paste that text box and button and some CSS and call it good. But there's actually a lot of value that can come by packaging that up into a component. There is a little bit of interactivity, as I'll show. You want maybe the button to be disabled until something's been typed into the box, things like that. And those are details that you typically aren't going to sweat if you're just copying and pasting. But if you can build something that's going to get reused across many, many applications, it suddenly becomes worth it to get those details right. So let's create a little text input control. I've got a web page here. It doesn't do a lot that's super interesting. It just shows a header. And what we want to do is I've got an empty file here called text input with button. We're going to import that into our project. And with that, what we're going to want is someone to be able to use it by putting the tag in there. So what we want to do is fill this blank canvas with the definition for that component. This will bring us to our second library, Polymer. So Polymer is a framework that's geared towards making it easy to create web components. It does that. You use markup to create the components. It looks like and feels like HTML. There's a bunch of extra syntax that they're adding in there. And as I mentioned, like with every framework, it's a package of conveniences for people who understand how to do things in a certain way. So it takes a long time to sort of come up to speed and learn how to do things the Polymer way, but there is this payoff. It's going to be faster. You don't have to build web components this way. You can. There's a lower level set of JavaScript APIs that you can take advantage of to register a custom element with the browser or respond to bindings, events, things like that. So you can do it that way, and there also are other frameworks that people are creating for creating web components. So I'm just going to show Polymer. It's a Polymer event, and at the moment, I think this is the state of the art in creating web components. So that's what I want to show you. To use Polymer in a project here, we're going to start out with another import. And we're going to import Polymer. And with that, this page can now understand a bunch of new tricks, like how to create a new element. I'm going to create a new element called text input with button, and I'm going to do that in markup. Everything I put in here is going to be the definition of that component. Now, the most common thing for a component to want to do is to populate the DOM with a set of elements. That's sort of the typical thing when you're running a plugin. Sort of step one is you're given a handle to a div somewhere, and you go fill it with a bunch of stuff. So in the case of web component, the standard way to do that is with something called the template tag. And this is our fourth spec. Templates is a feature not of Polymer, but of the new web platform. It's part of web components. And a template can be used outside of Polymer. A template is just a static collection of HTML elements that have no effect on the page. They're just used as the basis for copying. So you can quickly take a template and stamp out copies of it. That's what it's meant to do. And so that's what we want to do here. We're going to have our template to say hello world. And then there's one little other thing. This element is basically ready to be used. There's one more thing I need to do. I need to tell Polymer that there's no script. I haven't written any JavaScript to go with this. And with that, if we go back over to our page, we now see that component running. If we look inside of the debugger, we see that there's a text input with button element, and it's got a shadow document, and inside that there's a template. Hello world's not that interesting, but you can already do some things, some nice tricks. I can copy it and now get two of those things. So at this point, I've already got something that's basically like an HTML macro. I can have a collection of elements and styles and create copies of them, and then change them once and have them have it update everywhere. Each of these things now has its own shadow document, and these are copies. They're not shared. So for example, if I go and update one, it's just going to update in that copy, not everywhere. So now we don't want to see it's just static text. What we want to see is an input with a button. So here we see two text boxes with two buttons. Okay, and if we check in the shadow root, we see that that's what we've got. So this is starting to get interesting. Now, obviously, we want the page to be able to do something with this component. We want the page to know what the users typed in it. We want the page to know when the users click that button. In an old school way of doing things, the page would sort of go into the plugin's set of elements that it's put on the page and find the button and then wire up an event handler to it directly. Or if it wanted to stick text into the text box, it would go search for the text box and jam text into it. And this creates some really unhealthy entanglements between the plugin or widget and the page outside, because it locks the developer of that plugin into a particular DOM structure, because now people are depending on things being in a certain place or called a certain thing or having a certain class. A better way to create things that are reusable is to have every component have a contract, an API, with the page or other components. And as long as it's fulfilling that contract, the internals of the component can be revised without the page needing to be affected. So what we want to do is let's build a little API for this thing, and we'll start with we'd like this outer component, text input with button, to have an attribute that we can set on it. So I want to be able to set the default value to some string by setting a value attribute on this element. So let's do that. There's some Polymer syntax for that. So we have a value attribute. And whenever this value attribute is set, we want to stick it into this input box. And whenever someone wants to read that value, we want to get it from the input box. So there's a mapping that the component's going to do. It's not going to let someone talk directly to the input. And we could do that in script. There's some Polymer syntax that we can use to make that a little easier, and that takes advantage of our fifth spec, object.observe. This is a lower level spec. Eric Bottleman didn't mention it in the original set, but it's often used in components, and it's a key part of making components easy to wire together. And it basically enables a form of bindings. If you've used MVC frameworks, there's a lot of times you have something in a view and then some data object, and you want to be able to wire those two things together so that changes in one update the other automatically. Object.observe allows that to be a fundamental part of JavaScript. You can take a DOM element and say, I'm interested in changes to properties on this thing. Let me know if the following property changes on this object. And then every time that happens, you automatically get notified. So we can wire up a binding in Polymer with some exciting, cryptic, almost tautological syntax here. Value equals curly braces value. And the way to read this is to say the value on the text box is equal to the value on this outer component, and vice versa. So those two things will be kept in sync. So we go over to our page. Let's see. Yeah, so here we have that default text being put in there because we set an attribute on it. And if we were to look at that thing programmatically, it has a value property now. And we can manipulate it programmatically. So we could do through script, we could set that and read and write that value. And when we set the value on the outer component, because of the binding, the data will get put into the right spot in the UI. So this is a very simple example, but the point is that later on we could go and change this input to some other kind of element. Maybe we have a fancy autocomplete text component, and we can maintain that. We can maintain the same contract that this value is being exposed to the outside world, but the actual user interface to edit that value can be radically different inside, and the outer page doesn't need to be any the wiser. That's a key ability that unlocks a lot of reuse. Components like HTML elements, you put data into them either by putting content inside or by setting attributes. So let's just do a quick example where we want to be able to change the label of that little button. Right now it defaults to go. We want to change it so that it's something else. We could do that by creating a new attribute called something like the button label attribute. But I want to show that we can also do that with content. Let's say that we want this component, any text that's put, or other elements that are put inside of the tag, we want to show up as the label for this button. And there's some syntax we can use here. Content is, you can think of this as like an insertion point or a placeholder. Anything that's put inside of a text input with button tag is going to go into this content thing. So we go here. Well, one of them works. We see that we have our search text here. This guy lost his label, and that's because we took out that default. We can put that back inside this inside this content element. So that's saying, put the content of the tag here unless there's no content. If there's no content, use the word go. And so now we see this. Not too interesting yet, but because this is different from an attribute. It's not just text. We can do other stuff. So maybe we want to have a super enthusiastic search box and use the M tag. So we could put graphics in there. We could put a little magnifying glass icon. We could put anything we want in there, and it'll go into that button. And this is an important principle of components, is that they're not just dealing with strings or JSON. They can deal with DOM, and that means you can take, for example, that basic carousel component took a set of its content. It took all these images and did something smart in terms of laying them out into a sequence you could navigate between. Let's actually wire up one of these buttons so they do something. In HTML, you set attributes. You get when an element wants to let you know something's happened, it does that with an event. And you do the same thing with web components. You can define events. So let's create an event that is going to get triggered whenever someone clicks that button. To do that, we're going to go write some script. And so I can have script in a component, just like I can have script in a web page. There's some magic Polymer syntax. Anything I put inside of these curly braces is going to get added to the prototype for this new component. So I can add methods, property getter setters, anything like that. So I want to have a method called go. And for now, let's just have it say hello in the console. And we want this method to be invoked every time someone clicks on this button. We can wire that up with more exciting magic syntax. So this says every time the buttons click event fires, invoke this component's go method. When I sit go, regardless of which button I click, I get go in the console. So that's the first step. We've now got the button doing something interesting. The next step is to raise an event. If you're used to jQuery, you do like a trigger, and then you're going to sync the event with on. Just as an aside, Web Components solves so many of the problems that jQuery originally set out to solve, and browsers have just gotten better, that personally I found about 1.5 years ago that I just didn't use enough of jQuery. I was only using a tiny percentage of it, like raising events and syncing events, and then realized, that's just not a hard job. There's a DOM API for doing that. It's not that hard to learn, so I can use the lower level DOM API to raise the event. And I've stopped writing jQuery code altogether. That's not something you have to do, but the point is that web components solve a lot of the same problems. And we can create an event here called go that's going to bubble up through the DOM when the user clicks the button. And with that in place, we can go out to our outer page and listen for those events. We'll use the DOM API for events. And let's just say, actually, let's show the current value. So when I click the go button now, an event is generated. It bubbles up through the DOM. The outer page noticed that something happened inside the component. Importantly, it didn't know, the outer page doesn't know that there's a button there. It didn't get a click handler. It got something at a higher semantic level. It knows that the component is saying the user wants to go. And then the page can say, oh, okay, well, what's the current text? I'll do something with it. And so in this case, it shows it as an alert. So we're creating a tiny little toy component here, but it's got the beginnings of an API. You can put content into it and then events out of it. We can then go and improve it. Maybe someone looks at this and says, yeah, this looks terrible. Like, can you do something about the visual appearance? So let's add some stock styling. I mentioned before that general purpose components should have very generic styling so that they can be used in a wide variety of cases. We're going to use this host selector is a new CSS selector, often used for components. And we're going to say that everything that's, we want to stop both this input and button. We're going to give them a border, take away some margins so that they line up. We'll give them some standard padding. So it looks good. It's trying to look better. There's a little gap here that I want to close up. So I'm gonna. There's a couple ways to do it, but I'm just gonna hack it and just delete that white space. And then I'm gonna get a little fancy. Let's.
Border rate.
Oh, you got your border raised. Okay, so this is starting to look a little more interesting. This might be good enough as the sort of default implementation, but maybe your site has a blue theme and you want your stuff to be blue. So I mentioned before that we can take advantage of that shadow selector. If I say I want to have all the buttons be blue, nothing happens because there aren't any buttons on this page as far as the page is concerned. But if we make explicit use of that shadow selector, backgrounds are blue, and we can go change border color, say. Fun CSS color names. Okay, so this is starting to feel like something that someone might want to use on their site. One of the key points here is that the person who's working on this component can keep making it better without the page needing to do anything and without breaking the page. So, for example, here, if I click the search button here, the page gets an event, and so it says, okay, I want to do something with undefined because, well, there's nothing typed in, there's no value set on that thing. And the page could handle that. The page could say, okay, if I could check to see if the value is undefined, don't do the thing that I would normally do, don't go do the search. But really, that's an interactivity detail you'd like the component itself to handle. The component shouldn't let someone click that button unless there's something they can actually do there. So that's the kind of detail that we can now get right. We're going to use more exciting binding syntax. It's all Greek to me. Okay, so this says the disabled property of, I'm sorry, I put that, yeah, on the button should be set if the value is not set. So now we have this, and if I type, the button gets enabled. And if it's empty, the button gets disabled. Significantly, if I come in here and set the value through script or directly in the console, that triggers the right behavior because of those bindings that have been set up. We'll do, let's see. We started a little bit late.
Yeah, we did.
Okay,
Yeah.
I'll go.
We started about 2 minutes later.
Okay, so I've got a few more tricks that I want to do here. I want to add behavior right now. This component. If I'm sitting here pressing the Enter key and nothing's happening, and I really, really want something to happen, so we're going to go wire up a event handler. We say if you press the return key and there's a value set, invoke the go method. So here we're getting our own event handlers are taking advantage of our own API. So now if I come here and hit return, it does the go thing. Again, these are details that are often overlooked because you're busily trying to crank out functionality. I can't count how many times I've gone to a website that has a menu bar, and the interaction on the menu bar is just atrocious. Like, it forgets to put stuff away when you click outside of the menu, things like that, because someone was so busy, like, well, how hard could a menu be? I'll just have something appear on hover and then put it away when the user moves the mouse away, and the thing is just really brittle and broken. Components, these sort of bread and butter things like menus, toolbars, hold to refresh, whatever, they seem really simple, but they have a lot of subtlety to them. And so by reusing implementations, you can make them a lot more solid.
Question.
Yeah.
So you used a couple attributes that had hyphens in their name. Those are not standard attributes that are like they're not a standard event binding mechanism.
These things like on key press, that is Polymer syntax. So that's everything that's going on. And let me make this point. This is Polymer syntax. It's a set of opinions for how to create web components, and so they've had to invent a bunch of stuff. It holds up pretty well. I mean, I think it's fairly well thought out, and I find it, Component Kitchen, my startup site, is completely built with web components, all built with Polymer, and in general, we think that it's outrageously productive. But I don't want people to get too hung up on this syntax. It's just a framework, and I want you to appreciate the difference in time scale between a change to HTML or CSS and a framework. So someone invented CSS 20 years ago, we're still using it today. We're not using the frameworks that they came up with in 1995. We've got better ones now. So there's sort of a, the web components themselves is like a change on a geologic time scale. Like this is going to be permanent forever. Polymer is something that will have a lifespan. I don't know. jQuery was invented in 2006. So it's been 8 years. Kind of hard to believe that. And that's a good long run. As I said, I'm not using it. I stopped last year. So for me, it had a 7-year run, which is fantastic. I got a lot of mileage out of jQuery. It kept me from going nuts and killing myself over IE6. It had a role. A framework like Polymer or React or whatever, they all have their role, their time in the sun. If I look, ahead. Let's say jQuery is 8 years old. If I look ahead 8 years and imagine, in 2022, how are people creating web components? I don't know if they're creating them with this syntax. I don't know if this will still be state of the art. But they will be creating web pages with this syntax, because this is the core changes to HTML. They will be creating elements by putting them in angle brackets. They'll be putting attributes on them. They'll be sticking stuff inside of content. They'll be styling them. They'll be wiring up event handlers, because that's how elements work in the DOM. And unless there's something better that comes along, we'll still be creating web apps that way. So the way you use components will remain constant regardless of how those components were created. And it's important to know that when you're using a component, you don't need to know that it was created in Polymer, or that it was created with Mozilla's Xtag framework, or that it was created in raw JavaScript. That's immaterial. Once you've brought it into your page, you've imported it, you can use it, and you're using it just like any other tag. Same thing with, it goes for, in reverse, if Angular, if you're an Angular user and you want to use a component, Angular doesn't understand web components. It just is thinking about DOM elements. It's thinking about DOM elements that have attributes and content and events, and so it can work with them. You might not, in 10 years, maybe you're not writing this HTML. Maybe you're dictating to Siri, I would like a search box, and it's going to spew this stuff into some file somewhere. But under the covers, this is what it's going to be creating. So maybe that's how I want to sort of leave this this little introduction journey through the specs and these libraries, is to think about the sort of relative permanence of this transformation. It's coming. It's been several years that I've been looking forward to it. It's been shipping in Chrome now for a number of months. I have a business that I've built, and it's entirely on top of this substrate. I'm very happy with that. I won't oversell stuff. I mean, like anything, it gets, I don't know, 95%, 98% of everything right. And you'll find after about a week, like the 2% that's going to drive you crazy. So it's not perfect. There will be improvements to these specs, and there'll be work that falls on top of it that makes it easier to work with. But it's already the best way to create UI. Like if you're creating, whether it's a web app for the desktop or a mobile app, I would argue emphatically that this is sort of the best way to create something. So I think we'll end this talk at this point, because you're going to be able to see it for yourself in the code labs to try stuff out. Yeah. So.
Take any questions?
Yeah, well, I can take some questions now. We'll do a Q&A at the end of the day as well, but we've got a little bit of time, so I don't know if anyone. Yeah, so
Can you repeat the question?
sure. Okay. So the question was, can you have more complex content? So so let's go back to that carousel example. For example, I had a set of images, and what else can I do? So this is the question of what a component does with its content is going to be up to the component to decide. So if you're designing a component, this particular component, Basic Carousel, comes from an open source project that Component Kitchen sponsors called Basic Web Components, and actually handles content of any type. So you can have components within components. You can have complex content. You can have text on your slides, whatever, and that's all gonna basically it's looking at its children elements. So you can have whatever is a child of this component is going to be considered to be kind of a slide in that little slideshow. Other components might be work differently. I think that for well-written components should be tolerant of any content and flexible with regard to that content. So, for example, even our toy little text input with button thing could handle arbitrary content in that little button. And so, if it's designed well, a component shouldn't make too many assumptions about what's going to go inside of it.
It's actually more, how do you handle when there's not like a diverse type of content, but multiple? So like, think of a mail item that has like a user tile, maybe a timestamp, a person's name, and then like a short piece of message. Because you only pass them one content. So do you like comma delineate like?
Yeah. So that's I can afterwards I'm happy to sort of go through in details the syntax because it's a little bit complex to explain. But the basic idea is that we had, for example, this content element that was going to pull out the content. You can actually add an attribute to this, and you can say I want to select from the content that's been put inside this tag. I want to find anything that's got the class name on it, and I want to pull it into this part of my visual tree. And I've got, I don't know, an email summary. If there's a summary, something stamped with the summary class, I want to pull that over here. So you can the component can kind of crack apart its content and sort of marshal it into different spots. That's effectively part of the component's API. The component saying, I expect to have content, and I expect, if you put in content that is of this, if you put images, I'm going to do this with them. If you put in text, so for example, I've done stuff where there's a component that, you've got a button, and if it has an image, it does something special with it, and if it doesn't, then there's some default behavior. So it uses this particular ability to select out content bits and then react to those differently. Yeah.
Not been added to the DOM. You use the DOM element on the template or template put result of the template put.
So the question is, can you manipulate the template before it goes into the DOM? That would be unorthodox, and I don't think that Polymer is really set up to do that, although there's nothing preventing you from do that. If you write a component in raw JavaScript, you're the one that's manipulating the template, getting the template from somewhere. Oh yes, I'm sorry. So the question is, so how does something like this select? How does that actually work? Is that done? When is that done? So much of the shadow DOM specification deals with this problem of you've got you have a set of content that's in the DOM and the outer page, and then you have a component with a set of insertion points. It's got its own shadow DOM tree, and then it's got insertion points where it's expecting to graft in content from the page. And a lot of the shadow DOM spec deals with this problem of taking a set of content, they call it distributing. So I want to take this content from the page and distribute it to the right spots inside of the component. That's done at runtime, and that's done live. So for example, if you programmatically manipulate the page DOM, the component that will cause content to be redistributed to the component live so that the content will flow into the right place. If, for example, he had an example earlier of a component that was going to show a line of email in an inbox, say, and you had, say, there was a status flag that you were going to add to the DOM, and then the line of the email was supposed to show some indicator if that status was set. That would happen live. You just manipulate the DOM, and the components pick up the new content. Yeah.
In terms of the shadow recursion, so you have this template that has an interface that you define with values, right? Can you expose another component saying, well, instead of just exposing the string value, what I'm actually going to do is expose another component, right? And so therefore, at the top level, you actually have a handle for that inner component to be able to manipulate its shadow DOM, its style sheet. So it handles full recursion.
The question was about whether you can a component can expose a component it's hosting, a subcomponent, expose that to the outer page. You can do that. You wouldn't do it with that this particular syntax, but there is a way you basically would write in the script. I would probably write a property getter that then returned a reference to that particular component. Although that it is something you'd have to undertake carefully, because you're basically adding the existence of that subcomponent to your contract. You're saying, I'm always going to have one of these for you to manipulate, and it's always going to have this particular, that thing is going to be there. So that would kind of lock you into that. But if you're comfortable with that, then yeah, you can do that.
Yeah, so I wanted to ask, so what are all the mechanisms of defining the contact between the page and the component? So there are attributes, there are content inside the new element. Is there a standard way to document this, or like a Java doc style documentation for this?
Yeah, so that's a great question. So let's look at, for example, basic carousel. So I don't know if you'll like the answer, but there is an answer. The answer is there's a convention called JSDoc for documenting things like properties, methods, events inside of JavaScript with @pragmas. So this is the basic carousel source here, and it uses a pragma to indicate this thing is an element. It can point to a demo, and then somewhere down here. Let's see. So here's a method. It says this is the method that's actually going to go to the next page, and it exposes that with a particular pragma. And then there's a variety of ways that you can things you can do with that. So, for example, on Component Kitchen, if we go to the documentation, the full details for that page, we see the documentation for that, and that's been scraped out of the source. The Polymer team provides a component that does something similar called core component page, which also will scrape the documentation out of the source for a component and generate documentation, a sort of end-user documentation for a component. So that's the way that it's documented today. Yeah.
Any lazy load components on the page, like say, in the viewport, I don't want to load something below the
So the question is, can you lazy load components? So they're just elements. I mean, fundamentally, anything you can do with a DOM element like a div, you can do with a component. So you can have an AJAX call that's going to go get some data, and then you can do document.create element, or however you're going to create elements on the page, populate it with the data, and then do an append child or whatever particular framework you're using to get the data onto the page. So yeah, that's you can add components to the page, remove them, manipulate them like you can with any DOM element. Yeah.
So on there, you're showing like that JavaScript within your component being loaded in the page. So is that JavaScript being loaded and blocking the page at the same time, or is that separate?
The question is whether script inside of the component is blocking the loading of that page. I don't know the answer to that question, and I don't want to give you the wrong answer. I don't think it's
isolated in any way.
Yeah.
Like a worker or anything like that.
Yeah. So we should find the right answer to that question. I don't want to make one up because it's a timing question. I actually haven't. I don't know if I've ever run across an issue where I had to know where the timing was. So I'll leave it at that. Yeah.
In practice, like in a suite of elements, like theming, because on one part we're talking about how you're using the element selector. You're on you totally have to have know the internal DOM structure. So how does it work in practice?
So that is. Remember I said there was about 5% that was going to drive you nuts. So that I would call an unsolved problem. Yeah. So if you have the observation that he made was that if I'm going to let someone style this input or this button, then and they've written styles to they've gone and written styles that are expecting to find that input and that button or things with a certain ID or class, isn't that tantamount to adding those things to the API, and I'm kind of locked into supporting those things forever? So the answer is yeah. Right now, that's sort of the way it works. There are a couple strategies for dealing with that. So one is that you always expose and document classes as the thing to be styled, rather than sort of pointing people at a specific ID or a specific element type, and that at least lets you swap out different kinds of elements. As long as they end up with the same class, they'll get the border treatment or whatever it is that you want. There is a component that the Polymer team has created, and I'm forgetting the name, but it's trying to deal with the problem of styling, of theming components. So there's a themable component. If you look in the set of Polymer elements, there's one called something like core theme or something. So they're sort of floating an answer to the question, hey, what about this way of doing it? But there is the specs themselves do not cover how to theme things, and so I think that it's we're going to end up going through a period where there's going to be inevitably like 4 different answers to that problem, and then finally the community will figure out, okay, this one, these 2 are the way to do it. But right now there's not a great answer to that.
Well, along the same lines as you're using IDs and classes, what about using role as a selector and not even throwing out IDs, for example, that kind of idea?
Yeah, so you could use role as something in a selector instead of using IDs or classes, but you'll still have the same. I think you'll find you'll still have the same challenge. The fundamental problem is that if you have a particular implementation inside of a component, like the existence of those left and right buttons in the carousel, and then you decide to change the way that works, kind of all bets are off. Is when someone's trying to style you, if you decide, hey, I don't want to have the buttons there anymore, and there's not even something with that role anymore. Now it's all with touch or something. Then there's it's an open question. What should that thing look like if you're applying the styles to it? So theming is still a question where there is some ambiguity, and using roles might let you operate at a higher semantic level, but you're still going to have this problem of exposing maybe a little bit too much of your internal details. So I'm waiting to see, I mentioned this basic web components project. I've spent a bunch of time trying to think about what's the best way to let people theme stuff, but there's no solid answer yet. And we're going to have more time, but I think everyone might be interested in sort of diving in. With these code labs, it's possible to, it's like reading, it's cooking by reading the directions in the back of the package. It's possible to like zip right through the code lab really quickly, like, okay, I put this in here and I stir this up and I cook it for 15 minutes and not really walk away with an understanding of it. So as Mike said, you might want to take some time, and you might try messing things up. Like, okay, well, it said to paste it here. What if I paste it here? What if I change it and try and break it a little bit? Sometimes that can lead to understanding as well. Okay, thank you.
Those slides. So we actually can take a little break now. Okay. Way early page. That was awesome. Thank you, Jan. That was a great summary of stuff. So I think what we're going to do now is take a little break to take a bathroom break, and if you want to get any more coffee and pastries, there's still a lot of stuff here. And I think we can finish the video too. So we're going to come back this afternoon. We'll do another live stream video for those who are watching at home in the afternoon when Jan talks about the advanced stuff. But we're going to do the code labs on our own here in the room. So thank you. And so because the bathrooms here are broken in the